In this lecture for Chapter 5, I'm going to talk about a topic that I did not write a written lecture for, and that is the methods for determining if the data values are normally distributed. This is discussed in the text in Mendenhall in section 5.6. So the basic idea is that not all sets of data are normally distributed. We spend so much time with a bell-shaped curve that we tend to think, or we could think, that everything does fall under the bell-shaped curve, and that's not necessarily true. If the data values are not normally distributed, then it doesn't make much sense to use the tools that are discussed in this chapter. And it also doesn't make much sense to use these methods to find the probabilities. In fact, you're going to be finding very incorrect answers, right? So we want to figure out, before we do all this, whether the data is normally distributed. And we're going to use two tools. One is the histogram, and the other is, which you're familiar with that already, and then the new plot is going to be called the normal probability plot. Now, if the data is normally distributed, the histogram will look approximately bell-shaped. It's as though you almost could draw a line through the tops of the bars, and it would make sense and say, well, that's pretty close to being bell-shaped. In general, it has to be unimodal. That means there's really only one peak. Also, you expect some sort of symmetry about that peak, and it's you're looking to see that the data is not particularly skewed one way or the other. Okay. What is a normal probability plot? That's a different one. Okay, in this case, the mean and standard deviation of the data is found, and then the z-values are calculated. Remember, the z-values are associated with that standard normal distribution. For the z-values, the mean is 0, and the standard deviation is 1. Then this plot is constructed. The z-values are put on the horizontal axis, and on the vertical axis are the data values. Now, if the data values are normally distributed, then the result will be a straight line. Usually, of course, all the points don't fall on a straight line, and there are some that deviate, so it's how far off they are and how many there are, and so it's sort of a judgment call. Okay, so now we're going to go to R, and I'll show you how to do this in R. I'll also show you how to do the last two, in a sense, I'm showing you how to do the last two homework problems for Chapter 5. The commands that we're going to use in R are hist, which you already know that one for histogram, and the other is a new one called QQ norm, and then QQ line to draw a reference line through the plot created by QQ norm. Okay, so here we are in R, and I'm going to look at a data set. This is not a data frame, it's just a list of numbers, and it's called rivers. And it's a length of some rivers in North America, and I want to see if this data is normally distributed. So first I'll do the histogram, H-I-S-T, and then just type in the name. And here is the result. And the result doesn't look too promising. So in the last question in the homework, you'll be doing this with a different data set, with a links data set, and you'll see that the histogram doesn't look like an approximate bell-shaped curve. It is unimodal, though. It only has one peak here, but it's very skewed. Okay, so now let's go look at the normal probability plot. So now we're back at the console window where we can type, and we're going to create the normal probability plot for that data set rivers. To do that, we use the command QQ norm and QQ line, and I'm going to show you a shortcut. R will complain, but it will work out anyway. So let's make sure I'm back here. Okay, QQ norm, and then I give it the name rivers, and then I put an ampersand, and then go QQ line and do rivers again. That draws the reference line. So remember the discussion on when I had the PowerPoint there. on how to create this normal probability plot. You had to take the data, which would be rivers, you had to find the mean, the standard deviation, then you had to find the z-values, then you had to construct a plot, put in the z-values on the horizontal axis and the data values on the vertical axis. The command QQ_norm does all that work for you. QQ line draws a reference line so you can see how far off you are from the ideal. And I'm putting them together on one line so that I can do the plot all at once. And you can see it sort of complains, but it still did it. And let's see if we can find, here we go, here's the plot. Right, it's going to call it a normal QQ plot. And what we see down here are the, see, these do look like z-values. Remember, the z-values having mean of 0 and a standard deviation of 1, so you can expect numbers like that. Here are the data values, and you can see that this is quite far off. Right, this whole section over here, I mean, all these values, they're so far off from the line that it's, you know, sort of invalidates any idea that this data was normally distributed. So these are the results that you're going to get for the last homework problem in Chapter 5, but you'll be using the data set links. Now we're going to look at another data set, and this one is going to be closer to being normally approximated or normally distributed, and I'm going to do exactly the one in the homework. Alright, so it's going to be Nile with a capital N, and it gives some flow rates or some flows of the Nile River, and here's what it looks like. So there you go, about 100 values. And again, it's just a list, it's not a data frame. Alright, so I'm going to make a histogram of Nile. I'll do that first. And here it is. You can see this doesn't look too bad. You could almost take a line if you could draw, which I'm not very good at drawing, but you could almost get a bell-shaped curve out of this, right? Almost. Not quite, but that's not too bad. Okay, and this sort of looks like the mean. So this is very promising, and we'll go now and do the normal probability plot and see what we get. Again, I'm going to do two commands at once, so I'll do QQ_norm and call it Nile. Be sure to use capital N, QQ line, like the space here. Again, type the data set, and we get the complaint, but we got what we wanted. And you see this is much, much better. Some of these data points, even some extreme ones, are right on the line, like this one down here, this one up here. We have a little bit of deviation here, but we can live with that. Okay, so this is the result you will get, and when you do this homework and you're ready to plot it off, I'm going to go up into the corner in the menu right above the plot, and you'll see the second button in is a print. So just hit it and print. Okay. There are a few other sections on this homework, and I'm going to show you now how to do them. The first is to create the z-values associated with Nile. Now, to find z-values, you would take the mean, the standard deviation, and you do a calculation, and there are 100 of them. But there's a way to do it in R with just one command, and that command is called scale. So I'll say z-values, and I'll use the scale command, and I'll just tell it Nile. Okay, so there's the on the screen there you can see the values of the Nile, and now here are the z-values. I'll print them off too. Okay, around 0 and 1 and 2, and that looks about right. But it's sort of confusing that way. I want you to do something else. I want you to sort the values. Here are the Nile values. Oops. Well, those weren't, there they are. You can see it starts with 1120, 1160, then it goes down to 963. I want to sort them in order. So let's say sorted Nile values, and I just use the sort command. Tell it Nile, and now they're going to be in order. take a look at them. You can see they're in order. Okay, let's do the same thing with the z-values. So the sorted z-values, will be sort, and just give it z-values. And those are all going to be sorted too. But I want to print them off one next to each other. So this is exactly what you're going to do for homework. So you can watch this video while you do the homework if you'd like. I'm going to combine both of these. These are vectors. And I'm going to combine them into a data frame so I can print them off, and it's easier to compare them that way. So I'll make a combo of them, and it's going to be a data frame, data dot frame, and I'll put this Nile values first, this one sorted so it makes some kind of sense, and the sorted z values. Remember, if you have any capitalization wrong, it'll, I won't like it, but you know how to correct it with the up arrow. Okay, so everything looks pretty good. And now let's print them off. And now you can see when you print them off, this is what you'll get. You'll get the Nile values here, and next to it the corresponding z values. And I want to point out a few things here. What was the mean for the Nile? It was about 919. Okay, so this is what I want you to mark on the homework when you print it off. Here's 919. Okay, here's the 0. It's 919, some change. Right in here was the mean for the Nile. What do you expect the z value to be? 0. Okay. Now for the Nile, the standard deviation was about 170. So if I look 170 counts, whatever this is, I don't know the units here, down from 919, that would be 749. So let's go at 749. There is a 749, and you can see that the so here I'd like you to mark that. That's -1. It is 1 standard deviation below the mean. So in actual units, actual data, it's 749. In the z values, it's -1. This is just in case you didn't believe that the z values actually worked. So let's go in the other direction, and I'm going to list my cursor, and we have to go up 1 standard deviation above, and that's at about 1090. There's no 1090, but you can see that approximately where it would be. This would be about 1 standard deviation above the mean for the actual values. That's in this column, right? And the z value should be 1, and it would be right in there, and that would be 1. So I sort of want you to mark that off and construct it that way. So here are the commands again. Let me summarize these. Okay, you're going to make a hist. Use hist to make a histogram of the data. You use QQ norm of the data, and use an ampersand QQ line of the data. Give it the data's name, and that will give you the normal probability plot to see if it lies pretty much on that straight line. For the one that actually is normal, that would be this Nile data. I'd like you to find the mean. Just, you don't have to save it for any particular purpose, so you can go mean, and there's the mean for the Nile. Standard deviation for the Nile. Whoops, I got an error there. There it is. And you can get the summary also. I think I asked you to do that in the homework, and you know how to do those commands. So here we have how to do that. Now I want you to get the z values. To get z values, okay, the z values, just use the command scale, and now you have the z values. To sort the data, use sort. You can give it another name, like I used S, but give it another name. If you don't give it another name, if you just write sort, that's just going to happen. Okay, there we go. And now let's sort the z values. I've gotten pretty far without a mistake. It's kind of amazing. Okay, combine them into a data frame. So I called the data frame combo. You can call it whatever you like. It's going to be a data dot frame. Put one of the vectors first. We'll put Nile first. Then we'll put the z-values next. Then print off combo and go look for the mean and one standard deviation above and below the mean, and note that on the z-value at the mean of the data values, the z-value is indeed approximately 0. It's only going to be approximate. One standard deviation above and below the mean, the z-value will be +1 and -1.